All right, so in the last video we ended with discovering a really interesting formula for the derivative of the inverse function. I've written up what we did in a little statement here. So when f is 1-to-1 and differentiable, and f prime of f inverse of a is not 0, seems like a strange requirement, then it turns out that f inverse is differentiable at the point x equals a, and here's the formula. You'll need to memorize this formula. F inverse prime of a is 1 over f prime of f inverse of a. And so I want to make a quick remark and then do some examples with you. And so here's my remark. We'll talk a lot more about this later, but it turns out that if f prime of x is always positive, or f prime of x is always negative, let's say for all x, then it turns out that f is 1-to-1. Quickly, why is that the case? This is saying the slopes of your tangent lines are always positive, always increasing, or always negative, always decreasing. And if that's the case, you can't possibly fail the horizontal line test. If you fail the horizontal line test, then at some point your slope has to actually be 0. All right, so that is going to be a useful tool for us to quickly check whether a function is 1-to-1 or not. So let me do some examples with you. Here we go. So let's see, the first one, I want us to consider, let's see, f of x equals 2x plus cosine of x. And I want us to show f is 1-to-1, and I want us to find f inverse prime of 1. And I have to warn you that there's something about these problems that can trip people up. One thing that people often want to do is they want to say, well, let's find a formula for f inverse, then I'll take its derivative, and then I'll plug in 1. And you need to realize that I don't need a formula for the inverse function to be able to use this formula. This result that we just found allows me to compute the derivative of the inverse without having a formula for the inverse. How cool is that? So let's work out this example and you'll see what I'm talking about. So first of all, if you compute f prime of x, you'll end up with 2 minus the sine of x. And I want you to realize that the most sine of x can ever be is 1. So the smallest this can ever be is 1. So this is what? This is always greater than or equal to 1, which is greater than 0. Right? So the point is the derivative is always greater than 0. And so we know instantly that f is 1-to-1. That's how you show it. You just check the derivative in this case. Now, I need to know two things to be able to use this formula. I'm going to maybe put those in purple over here. I need to know f prime of x, and I need to know f inverse of a. Those are sort of the two pieces that I need here. So I've already computed f prime. That was easy enough. F prime of x is no problem. There it is. I need to know f inverse of 1. So f inverse of 1, I can compute that without a formula for the inverse function. I don't know what f inverse of 1 is. I'm going to call it c. And I know that f inverse maps 1 to c if and only if f maps c back to 1. And rephrasing this question in terms of f allows me to look at this problem and think, okay, what value do you plug in for f and get out a 1? Well, if I plug in 0, I get out 0, and cosine of 0 is 1. And so you can actually see that wait, f of 0 is 1. And so the point is, so c equals 1. And what I want you to actually write down is f inverse of 1 is 1. And I don't need the formula for, wait, I'm sorry, f inverse of 1 is not 1. Whoa. C equals 0. I don't know what I'm thinking. This is why you don't do math on a Saturday morning. So C equals 0. F f of 0 is 1, so c equals 0, and so f inverse of 1 is 0. There we go. All right, I've got f prime, I've got f inverse of 1. And now I'm ready to tell you what f inverse prime of 1 is. The formula says it's 1 over f prime of f inverse of 1. All right? Well, we know f inverse of 1. We just figured out that f inverse of 1 is 0. So this becomes 1 over f prime of 0. Look at your formula for f prime. Plug in 0 and you get out a 2. So this is 1 over 2. Done. And so if you want to summarize, you can say, okay, f inverse prime of 1 is 1/2. There it is. So let's run through this again, then we'll break this video and do another one. So what are we doing? We're using our formula that says f inverse prime, the derivative of the inverse function at a point, is 1 over f prime of f inverse at that point. And so I just need to find f prime, f inverse of the point, and I did that, and I worked it out. So I'm going to break this video here. I'll do another example in the next video with you.